So hello student, in this video we are handling differentiation from first principles, but it is a very simple algorithm. So if we have maybe differentiate from first principles, differentiate from first principles, differentiate from first principles, let me say differentiate maybe y is equal to x squared by first principles, by first principles. How would we do that? So we shall assume that our f of x, which is the y, is equal to x squared. You're there, such that if I have the f and then I get the x plus a small change in x, you're there, what will it be? It would still be the x plus a change in x. By definition, this guy is squared. You're there. But then we have, in the former video, we have defined the differentiation as a change in y dy dx. You're there, which is defined by the limit as the delta, or the change in x, is tending to 0 over the y change in y divided by the change in x. You're there. So the change in y is this guy. The change in y is the f of x plus this guy, then minus the f of x divided by delta x. In the former video, we have seen how we reach this formula. So such that I'm going to have now the limit as change in x is going almost to 0. So over now this guy is the same as x plus the change in x, this guy is squared, minus my f of x, which is x squared, divided by delta x, such that if I expand this guy, I have the limit as change in x is tending to 0 of x squared plus twice x change in x, then plus the delta squared. It is delta that is squared, x minus x squared divided by delta x. So the dy dx is equal to the limit as the change in x is tending to 0 over 2x dx plus the change squared in x divided by change in x. So the change in x, this and that, then I remain with the other guy, so that I have still the limit as the change in x is going to 0 of 2x plus the change in x. But you know what, now I take the limit as change in x goes to 0. If that guy goes to 0, my dy dx simply goes to 2x. So if differentiated that guy from first principles. It is a very simple algorithm. Maybe in the next example, let us see how we use the second method. So let us try to use a second approach. Maybe it can be simple to someone or any other person. So we know that our y is equal to an x cubed. You're there. But then to use the concept of differentiation, we are using small changes. So if I can have y plus a small change in y, you're there, what would this guy be equal to? If I have a small change in y, then I'm going to have a small change in x. I take a small change in y with a corresponding small change in x. So I'm going to have x plus a small change in x, and the whole of this guy has been cubed. You're there, such that I can expand out this guy. If I expand out this guy, if I expand out that guy, I'm going to have my y plus a change in y. This will equal to x cubed plus a 3x squared, yeah? The change in x plus a 3x change squared, yeah? Change squared in x plus the change in x cubed. In our videos, we are going to be seeing how we obtain these coefficients using Pascal's triangle in the subsequent videos. So such that if I take this y the other side, I know that the value of y is x cubed. If I take it to the other side, it means the x cubed goes away, such that I remain with a change in y that is equal to a 3 x squared change in x plus a 3x change squared in x plus a change cubed in x. So what I do here, remember, I need to obtain the change in x with respect to the change in y with respect to change in x. So what I do, I divide through, I divide by everything by change in x, such that I have change in y divided by change in x as equal to, when I divide this guy, I remain simply with 3x squared plus 3x change in x plus change squared in x. You're there, such that now I can take the authenticity to take the limit as change in x is going to 0. But when I take the lim as change in x goes to 0, this guy goes to dy dx. So if I take the lim or the limit, yeah, the limit of my function, the limit of change in y divided by change in x, yeah, as small change in x is tending to 0, the limit of this guy is dy dx, meaning that my dy dx dy dx is equal to the limit on this function, is equal to the limit as change in x is going to 0 of 3x squared plus 3x change in x plus change squared in x, meaning that my dy dx, this guy goes to 3x squared plus 0 plus 0, because the change in x has gone to 0, change squared, that is 0, meaning finally my dy dx is simply equal to 3x squared. Dy dx is equal to 3x squared. Yeah, so that is basically how we differentiate from first principles. In case you have any questions, you are free to inbox me, and I hope you privately, or maybe you could be having a disturbing number. Yeah, feel free to inbox me, but don't be selfish still. Yeah, tell your friends to watch these videos, because they are good enough. Yeah, they can make you the best of mathematicians. Otherwise, consider subscribing and liking our videos. Hit the notification button such that you don't lose out. Yeah, otherwise, thank you. Yeah, so in our next video we are continuing with our differentiation.